Welcome to Train Signal. You're watching a lesson on power supplies. Now, real quick, before we get in and look at the actual power supplies themselves, there are some basics of electricity. So this is going to be kind of like electricity 101 here that we need to go through. You need to understand certain concepts first. So the first term, really, that I want you to know about is something called voltage. Okay, or sometimes we just say volts. Volts have to do with the force of electricity, how powerful, how forceful the electricity is. A couple examples I have here is this would be an example of a very low amount of force, right? The water is just kind of trickling out of these pipes. Whereas here we have a high amount of force. We have the water is just thrusting out of the pipe really hard. Okay, and that would be the example of voltage. When you see that something is low or high voltage when it comes to electricity, it's the amount of strength of the power, the force of that energy. But then we have amperage, or what's sometimes just called amps, which is the current. Okay, and the current has to do with how much, right? What's the quantity of electricity? It's current, so it's the flow of electricity. Okay, not how powerful, but the flow of it and how much of it. So here's an example of a low amount of current, right? A trickling little stream versus a high amount of current where we have a big river. Okay? And then we have ohms, which is resistance. Okay? So this is the opposition to the electricity. What's pushing back on the electricity? So here we have an example of a low amount of resistance. Right, we just have Beaver Dam that was created. It's just a bunch of twigs and stuff that's kind of interfering with the flow of water. Whereas here we have a high amount of resistance where we have a whole dam that's been built, and if we close off the dam, we can completely stop that water from flowing if we wanted to. Okay, so I want you to think of those at all times, is that you have a certain amount of force, you have a certain amount of flow, and then you have a certain amount of resistance to that flow. Now, watts is the actual workload. And the way we calculate watts is by taking our volts, so take however much voltage there is, and multiply that by how many amps we have. And what we end up with is wattage, the actual workload. For instance, when you pay your electric bill, you'll pay for a certain number of kilowatt hours, and it has to do with how many thousands of watts you're going through, how much workload, how much electricity has actually been sent to your house. Now, here's another big thing that you need to know, especially when it comes to power supplies and the purpose that they serve, is understanding the difference between alternating current, which is what is used by most homes and businesses. So, when you plug something into the wall, the type of electricity that is coming out of that wall is something called alternating current, where the direction of electricity changes back and forth, typically running at a frequency of about 50 to 60 hertz. We learned in the processors lesson that a hertz represents cycles per second. And the voltages of our alternating current range from 110 to 230. And again, 110, some people say 220. Some others will rate it at 230. Instead of 110, sometimes they'll say 115. Okay, so there is that variable. A lot of times you'll see 110, 220. At least here in America, that's how we'll look at it. You got the 110 and the 220. The other thing I will tell you is here in America, your typical outlet has 110 volts. Whereas I know over in other countries, like over in Europe, typically you'll have 220 or 230 volts in those outlets. And then you have direct current. Okay, and that's where I say that the power supply, that I say that's a big role that it plays, is the wall outlet in a house or a business is giving off alternating current, but a lot of the various devices, right? We have many different devices, even inside of the computer, the different components. They need direct current to operate, and the power supply converts it for them. Okay, so the direction of electricity is constant. It's always one direction or the other. And the voltages vary by device. So now that you know those basics of electricity, And that really was the overall basic of all electrical basics. There's so much more to know. But that right there, even if you just remember the part about the alternating current and the direct current, and remember that the power supply, the design and the purpose of it is to go ahead and take the alternating current in, right? That's how you're plugged into the wall outlet. You take that current in, you then will have that energy stored in the capacitors of the power supply so that when the various devices inside the computer need power and they need it via direct current, the power supply will then distribute that electricity via direct current from those capacitors. All right, so let's take a look here. Here I have a typical power supply, right? This is what they look like. They look like a box. Obviously, they come in different shapes and sizes depending on whether you have a tower computer or more of a mini tower or a desktop or a laptop, or all sorts of different computers are going to have different sized power supplies. But here's what a typical one looks like. It's just a box. And what are some of the components that we typically would see? A fan. Okay, we have power going through, so we want to have an exhaust fan. And this exhaust fan serves a couple of purposes. It does exhaust heat from the power supply itself, but it also helps to keep airflow going through the computer itself. Okay, so it's a way of exhausting heat from the computer. You have a power switch. Not all power supplies have this. Most of them these days do. Sometimes you'll have an actual physical on-off switch. Sometimes you just plug them in and unplug them, and that's the only way you turn them on and off. Speaking of the plug, there's your three-prong power receptacle, your typical power receptacle to plug it into the wall. And then another feature that some power supplies have and some don't is a voltage switch where you can switch between, and actually looking at this picture very closely, I can tell it says 115, not 110, but 115, or 230. So you switch between your 110, 115, or your 220, 230, depending on what type of an outlet you're plugged into. And I will tell you, by the way, when it comes to troubleshooting a power supply in a computer that won't work, if you have one of these switches on it, look to see if it got flipped. Now, I'm going to tell you, this is all you should ever see when it comes to the power supply. This is all a power supply should ever look like to you. I am going to show you the inside of one in just a little bit here, but you should never be inside. This is all you should ever see. What I do want you to also be familiar with is all the various connectors that will be coming out of the power supply. By the way, I would like to point out that the power supply you're now looking at does not have one of those voltage switches on it. Okay, just to show you that different power supplies are going to have different options. It does still have an on-off switch, though. All right, so here we have this whole maze of connectors. And one power supply might actually have all these connectors. Many of them have fewer. Some of them even have more. So what are some of these different connectors? Well, we have our 20-pin P1 connector and then our 24-pin P1 connector. And what do we mean by P1 connector? These are the connectors that would plug into a motherboard. Okay, so back in the motherboards lesson, we talked about form factors and making sure that you have a power supply that matches. You have to have a power supply that has the appropriate motherboard connector to give power to the motherboard. Some power supplies will actually have both of these connectors, both the 20 and the 24-pin connector. Some will only have one or the other, and then you have to make sure you have the correct one. Here we have a Molex connector, and this is the connector that would plug into your old PATA, your parallel ATA hard drives and optical drives. Would be the most typical devices that you would connect a Molex connector to. So if you go back to the storage lesson where we looked at the different storage devices and I had mentioned about the PATA drive we were looking at and the power connector, well, this is where I was referring to when I said we'd come back to it. There is something called the mini connector, which was used to connect to floppy drives. So if you have a computer that still has a floppy drive in it, that's the type of power connector you need. Here we have the SATA power connector. Okay, so if you now are using SATA storage devices and optical drives, this is the power connector you need. And then we have our PCIe connector, which would give power to certain PCIe devices. And one other type of power connector that I'd like to talk to you about here, and it's funny because the picture that I have here is actually an adapter, not the actual connector, but I wanted to show you that it comes in both 4-pin and 8-pin. Okay, and this is a 12-volt power connector that is specifically designed to provide power to the CPU or a processor. Okay, so please understand that it does have, some come with 4-pin, some come with 8-pin. I've also seen where sometimes the processor has 8 pins, but if you have a power supply that only has a 4-pin connector, you have two options. You can either get an adapter like I have shown here, or there are in some cases a way to go ahead and plug just the 4 pins into the slot, into the correct 4 slots and get it enough power. Okay? It's not recommended, but it is something that I've seen that you can get away with. All right, so, these are some of the various connectors that you may find and you want to be familiar with on your power supplies. Now, when it comes to installing a power supply, now I'm going to show you the actual installation in the lesson where we actually build a computer. And I will tell you there's not much to it. More often than not, it's a matter of sliding it into a chassis and, if anything, screwing in 4 or 6 screws to hold it in place. And that's really all you should ever be doing with it. But what you do need to pay attention to is making sure that you're installing the correct power supply. And so what do you want to pay attention to? Well, number one, you want to pay attention to the wattage. Different power supplies are rated for a different amount of workload. And what you want to do is you want to look at all the various devices that you're going to be supplying power to and look at how many watts they require. And when you add that all up, make sure you have a power supply big enough. And when I say big enough, I don't mean physically big enough, wattage big enough. But speaking of physically big enough, size, that's the other thing. Now, in most desktop computers, we've gotten to the point that power supplies are a fairly standard size, and it's not that big a deal. But you do still need to pay attention because they're not guaranteed to all fall into that one standard size. Okay, certain boxes are oversized. Maybe they're designed for high-end servers, and you need to have a bigger physical power supply. Typically, and although not always, the larger the physical size is, the larger the wattage is going to be as well. All right, so you want to make sure that you have the right sized power supply to fit into your box. You want to pay attention to the number and selection of connectors, right? Make sure that you have the selection that you need as far as Molex versus SATA. Make sure you have the right motherboard connector and things like that. But make sure you have enough of them. If you know that you're buying a power supply for a computer that has 6 hard drives in it, well, then you're going to need to make sure that you have enough connectors for those 6 hard drives. Now, I will also tell you that there are expansion connectors where they're kind of like splitters, where you plug in 1 and then it becomes 2 or 3 additional connectors. And that's fine, but the one thing you want to keep in mind is that usually the power supply, its rating in wattage is going to also then dictate the number of connectors based upon an estimate of the knowledge of the types of devices you typically would connect to and what types of connectors they're going to require. So you want to be careful if you're using those splitters because you can overwork the power supply and burn it out a lot faster than it otherwise would. And then the last thing is the form factor of the motherboard, which really relates kind of to the number and selection of connectors. You want to make sure you have a power supply with the right motherboard connector. So it kind of relates. Really just kind of the 3 items, I guess. Now here is what I was talking about. This is what the power supply kind of looks like. It gets even more intricate if you dig deeper into it. But this is what it looks like if you take the cover off. And guess what? You shouldn't do it or you might end up looking like this. Power supplies are a dangerous electrical device, even if they're not plugged in. And I can tell you from a number of different experiences, both involving other people and even myself. Now, fortunately, the instance involving myself was not a big deal. I had actually touched a capacitor that even though the power supply was unplugged from the wall, it still was holding on to enough power in those capacitors. They don't discharge instantly. That I got a little bit of a, just a little bit of shock, a little warm and tingly feeling, as I would describe it. It is kind of a burning sensation. But I also know other people, and I've witnessed them when messing with electrical stuff that they're not supposed to. I've seen all kinds of crazy stuff. I've seen screwdrivers thrown across a room. I've seen people with burn marks on their body. For the most part, power supplies, they don't cost a lot of money. You shouldn't be messing with the inside unless you are a trained electrical engineer. If one goes bad, all you should be doing is not unscrewing the cover of the power supply. You unscrew the power supply from the chassis of the computer and you take it out and you put a new one in. And believe it or not, that's all I have. It brings us to the end of the lesson. It's real simple. Power supplies. They are needed to convert alternating current from the wall to direct current to our devices to make all of the insides of your computer work. And the only other side note I'm going to throw in, even though we just mentioned it at the end, they are still dangerous even though they're basic. They are dangerous electrical devices. Don't mess with them. Don't mess with the insides of them. Just replace them. It's much easier. It's much more efficient. So that's all I have for you. I thank you for watching, and I will see you in the next lesson.